Determining whether a well that's reached the casing point will produce enough oil or gas to make completing the well economic requires being able to make an initial estimate of the amount of oil or gas present in the reservoir rock penetrated by the well. While there are several ways of doing this, the one that is typically done first is the volumetric approach. This is because the volumetric approach is simple, requires the least data and assumptions, and can be done quickly based on the geologic model of the reservoir and the well's initial results. The volumetric approach requires measurements and/or estimates of the following parameters. First, you need the average horizontal area of that part of the reservoir that contains oil and/or gas, a region I will henceforth refer to as the gross pay zone. Second, you need the average vertical thickness of the gross pay zone. Third, a percentage of this thickness that actually contains oil or gas is required. This percentage is known as the net pay. Fourth, you need the average porosity of the reservoir. Fifth, you need the percentage of the pore space that is water, or the water saturation in the reservoir. And finally, you need the formation volume factor. This last parameter is the fractional amount that the volumes of oil or gas in the reservoir have been changed by the temperatures and pressures in the reservoir relative to the volumes that the hydrocarbons will have at the Earth's surface. Let's run through each of these parameters, starting with the average horizontal area and thickness of the reservoir. To get a good estimate of these parameters, a well will need to be drilled through the gross pay zone down to where the reservoir contains only water. If the well stops above this level, the true thickness of the gross pay zone will remain unknown until the well is deepened or another well is drilled. The shape of the reservoir can be highly variable, with an important influence on the shape being the type of trap holding the oil or gas. For example, a pay zone beneath a domal trap has a shape that differs from a pay zone trapped by a fault through the reservoir strata, which is different in shape from the gross pay zone trapped by a lateral change in rock type. However, by using the geologic model of the reservoir and the depths of the top and bottom of the gross pay zone determined from the well, the average area and average thickness of the gross pay zone can be estimated and then multiplied to arrive at a volume that should faithfully approximate the actual volume of the gross pay zone regardless of the pay zone shape. This volume is then multiplied by a set of percentages that yield the volume of the gross pay zone that is just oil or gas. The first of these percentages is the net pay, which is that percentage of the gross pay zone that actually bears recoverable oil and/or gas. This adjustment is done because reservoirs are typically made up of alternating layers of rock, not all of which contain producible oil or gas due to low permeability and/or porosity. The net pay zone is then the thickness of the reservoir that contains recoverable oil and/or gas. In turn, the net pay zone is multiplied by the porosity of the reservoir, which is the volume of the reservoir that is void space within the rock and contains fluids. So this point in the calculation yields the total fluid volume of the net pay zone. The fluid volume is then multiplied by 1 minus the water saturation, or the fraction of the fluid that is not water. So we now have the volume of oil or gas. This volume is in turn divided by the formation volume factor, which converts the oil or gas from reservoir volumes to surface volumes. Finally, the remaining volume is multiplied by a constant that converts the surface volume into standard sales volumes, these being barrels for oil and cubic feet for natural gas here in the U.S. Note that this calculation requires different formation factors and surface volume constants for oil versus natural gas. So the calculation needs to be done separately for the two hydrocarbons using the appropriate values for these parameters.